Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. This video presents linear equation in one variable or in one unknown. So we define an equation as a mathematical statement that two expressions are equal. Then we also define an identity as an equation when members of the equation are equal for all admissible or permissible values of the variables. So by the way, the expressions in the equations are called the sides or members of the equation. So example of an identity is x squared plus y squared equals quantity x plus y quantity square minus 2xy. So remember that by special product, x plus y quantity square is x squared plus 2xy plus y squared. So then we have minus 2xy, so that's why the 2xy term will be eliminated, leaving on the right side of the equation x squared plus y squared. Then an equation that is true only for one or few permissible values of the variables is called a conditional equation. So example of a conditional equation is 2x plus 5 equals x plus 9. And for equivalent equations, the solution should be the same, or solution or root must be the same for this equation. 2x plus 7 equals 13. So these sides of the equation are only equal if the solution is the same and both the left and the right sides are equal. So when we use the word equation, it usually means a conditional equation. So solving an equation means finding a set of values of the unknowns or the variables which satisfies the equation. So when the equation or when an equation contains only one unknown, its solution is called the root of the equation. So to solve an equation means to find all of its solutions. So as mentioned earlier, two equations are equivalent if they have the same solutions. So the following operations yield equivalent equations or equation if addition or subtraction of the same numbers to both sides, multiplication or division of both sides by the same number as long as it is not zero and does not involve the unknown. So when we divide both sides of the equations by a value, then that value should not be zero. Remember that division by zero is not defined. So in this conditional equation, we just apply the rule that we can add or subtract equal terms from both sides of the equation. So in this case, 2x plus 7 equals 13, so we can subtract 7 from both sides of the equation so that we can eliminate 7. So this results to 2x equals 13 minus 7, so 2x equals 6. So divide everything by 2 or multiply everything both sides by 1/2. So x equals 3 for that case. So that's the solution. Then the following facts or rules lead to facilitating the solutions of equations. So first, equal terms from both sides of the equation can be cancelled by subtracting the term from both sides. And we did that partially for this situation here. It's like if we have 7 from both sides, so we eliminate 7, in this case, we eliminate negative 7 or vice versa. So a term can be transposed from one side to the other with the sign of the terms changed by subtracting it from both members. So it's like this. We subtract 7 from both sides of the equation. So as another example, 2x plus 7 equals 4 plus 7. So it's like adding the same values from each side of the equation. So it's also like subtracting 7 from both sides of the equation or transposing one value to the other side, and the sign will change. So the signs of all terms on both sides may be changed by multiplying or dividing both sides by negative 1. So we can also change the sign by multiplying or dividing by negative 1. So in equation with one variable, the equation in one variable or unknown in the term is in the general form ax plus b equals 0 when both a and b are known values and a should not be equal to 0, so that division by 0 cannot be formed. And remember, it is undefined. So x equals 2 for this case because 2x equals 4. Then 2x plus 3 equals 9. As another example, we can transpose 3 to the right. So when we transpose 3 to the right, it becomes negative 3. So 2x equals 9 minus 3. So 2x equals 6. So x equals 3 for that case. So your experiences in simplifying or operating expressions should be kept in mind in order to solve equations in general. So it is a good practice to check the original equation and or other correctly processed equation if satisfied by the solution or roots of the equation. So to make sure that your answer or our answer, the solution, is correctly arrived at, then we must perform checking of the original equation or the correctly processed equations. So as examples, let's have 6 problems here, solve and check. These are very elementary equations, but it is a good start for us or for you to develop skills in solving equations in one unknown or one variable. So there are 6 here, and let's check for the next slide or for the next video. We'll just check the solution mentally. So first we have to subtract or transpose 5x to the left, it becomes negative 5x. Transpose negative 3 to the right, it becomes positive 3. So x minus 5x equal minus 3 equals 5x. Then minus 5x, remember that we subtract negative 5x from each side of the equation. That's the rule. So I'll present solution to number 1 in a more detailed way. Then for number 2 and so on, we'll just make it short. The solution is short. So this becomes x negative 4x minus 3 equals 7. So add 3 to both sides. Negative 4x equals 7 plus 3, or we transpose negative 3 to the right, so it becomes positive 3. So negative 4x equals 10. Then dividing everything or multiplying everything by negative 1/4. So negative 4x over negative 4 equals 10 over negative 4. So finally, this is x in the left side, and in the right side, negative 10 over 4 or negative 5 halves. So then we check the original equation if it is satisfied by this to validate our solution or final answer. So negative 5 halves minus 3 equals 5 times negative 5 halves plus 7. So by fraction, this is negative 5 minus 3 times 2 all over 2 because the LCD is 2. In the right side, this is negative 25 plus 7 times 2 over 2. So negative 5 minus 3 times 2 is negative 11. So this is negative 11 halves. In the right side, negative 25 plus 14 is also negative 11 over 2. Therefore, negative 11 halves equals negative 11 halves. So that's checks our solution. So x is negative 5 halves. For the second part, we have to transpose negative 4y to the left and 5 to the right. So this is negative 3y plus 4y equals 2 minus 5. Remember that when we transpose, the sign will be changed. So negative 3y plus 4y is y, and 2 minus 5 is negative 3. Therefore, y is negative 3. Then we perform checking. 5 minus 3 times negative 3 equals 2 times negative 2 minus 4 times negative 3. So this is 5 plus 9 or 14. The right side is 2 plus 12 is also 14. So 14 equals 14, and that checks our solution. Y is negative 3. For problem 3, we have to transpose 7x to the left, negative 6 to the right. So this becomes 3x minus 7x equals 18 plus 6. So negative 4x equals 24. Dividing everything by negative 4. So negative 4x over negative 4 equals 24 over negative 4. So that means x is negative 6. And checking 3 times negative 6 minus 6 equals 18 plus 7 times negative 6. Negative 18 minus 6 is negative 24. The right side is 18 minus 42, which is also negative 24. So that checks our solution. So x is negative 6. So it is validated. Then we have to transpose negative 6x to the left, 4 to the right. So this becomes negative 3x plus 6x equals negative 7 minus 4. So 3x equals negative 11. Dividing everything by 3, so x equals negative 11 over 3. So we level up. Dividing everything by 3 is not shown here, but I hope that you can understand. We also divide the right side by 3. So leaving x in the left, so negative 11 over 3 to the right of the equation, and therefore the solution is x equals negative 11 over 3. So let's validate this answer. 4 minus 3 times negative 11 over 3 equals negative 7 minus 6 times negative 11 over 3. So this is 3 times 4 or 4 times 3, 12 plus 33, because negative 3 times negative 11 is 33 over 3. And the right side is negative 7 times 3 plus 6 times 11, or positive 6 times 11 over 3. So 4, or the other way is we just add 4 plus 11. 4 plus 11 in the left side. Then in the right side, negative 6 minus negative 7 minus 6 times negative 11 over 3 is positive 2 times 11, 22. So negative 7 plus 22. 4 plus 11 is 15. Negative 7 plus 22 is also 15. So 15 equals 15, and that checks our solution. Then for this problem, 4x plus 2x equals 8 minus 5 by transposition. So 6x equals 3. Dividing everything by 6, so 6x over 6 is x, and 3 over 6 is 1 half, so x is 1 half. Let's check that solution. 4 times 1 half plus 5 equals 8 minus 2 times 1 half. So this is 2 plus 5, 7. 8 minus 1 is also 7. So 7 equals 7, and that checks or validates our solution. X is 1 half. Here we have 3y plus 3y equals 1 plus 4. So 6y equals 5. Dividing everything by 6, so y is 5 over 6. So therefore, checking 3 times 5 over 6 minus 4 equals 1 minus 3 times 5 over 6. So this is 15 minus 4 times 6 all over 6. Then in the right side, 1 times 6 minus 15 all over 6. So 15 minus 4 times 6 over 6 equals 1 times 6 minus 3 times 5, 15 all over 6. So 15 minus 24 is negative 9 over 6. 6 minus 15 is negative 9, then divide by 6. So negative 9 over 6 equals negative 9 over 6, or negative 3 halves equals negative 3 halves. And that validates our solution. Y is 5, 6. So that's it for this video. We'll have more uh, equations to be solved in the next slide.